Find sine inverse of 1/2, which means we need to determine the angle whose sine is 1/2. The sine of an angle is positive in quadrants 1 and 2, but we restrict the domain to negative pi over 2 to pi over 2 so that the inverse relation is also a function and has a unique solution. On the unit circle, sine is the y-coordinate. At pi over 6 or 30 degrees, which is one of the common angles we often use, the angle forms a 30, 60, 90 degree triangle where the y-coordinate is 1/2. This angle is in quadrant 1 within our range. So the sine inverse of 1/2 is 30 degrees or pi over 6 radians. Find cosine inverse of negative square root of 2 over 2, which means we're looking for the angle theta whose cosine is negative square root of 2 over 2. Cosine is negative in quadrants 2 and 3, but for cosine inverse, we restrict the domain to 0 and pi to ensure a unique solution. On the unit circle, cosine is the x-coordinate. At 3 pi over 4, or 135 degrees, which is one of the common angles we often use, the reference angle forms a 45, 45, 90 degree triangle, giving the x-coordinate of negative square root of 2 over 2. This angle is in quadrant 2 within our range. Therefore, the angle is 135 degrees or 3 pi over 4 radians. Find tangent inverse of negative square root of 3. Tangent is negative in quadrants 2 and 4, as the tangent theta is sine theta over cosine theta. For the inverse tangent function, we restrict the domain to negative pi over 2 to pi over 2 to ensure a unique solution. At theta equals negative pi over 3 or negative 60 degrees, which is one of the common angles we use, the reference triangle is a 30, 60, 90 triangle, and the tangent of the angle is negative square root of 3. So the tangent inverse of negative square root of 3 is negative 60 degrees or negative pi over 3. Let's solve the equation for theta in the interval from 0 to 2 pi. 6 times sine theta equals 3 times sine theta plus 2. Our first step is to isolate the sine term. Subtract 3 sine theta from both sides, which simplifies to 3 sine theta equals 2. Next, divide both sides by 3, so sine theta equals 2/3. Now take the inverse sine of both sides to find theta, so theta equals sine inverse of 2/3. Now 2/3 is not one of the standard sine values we often use, so we need to use a calculator, which gives us 0.73 radians. This angle is in quadrant 1 where sine is positive, but since sine is also positive in quadrant 2, we need the second angle that gives the same sine value by subtracting the reference angle from pi, which gives us 2.41 radians. So within the interval from 0 to 2 pi, the two solutions are 0.73 radians or 2.41 radians. Solve the equation for theta in the interval from 0 to 2 pi. We're given 2 times cosine squared theta minus 1 equals 0. First, isolate the cosine squared term by adding 1 to both sides. Next, divide both sides by 2. To undo the squaring, take the square root of both sides, which gives us plus or minus square root of 1/2. And rationalizing the denominator, we get plus or minus square root of 2 over 2. Cosine corresponds to the x-coordinate on the unit circle. Looking at the unit circle, we find that cosine equals plus or minus square root of 2 over 2 at 4 angles. They are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.